What's up guys, welcome back to the channel. Today on this video we'll be doing this question paper that you see here. This is a national certificate for mathematics N5 which was written on the 27th March 2026. It was an X paper that took 3 hours to be written. So before we continue on this specific video, we'll be focusing on question 2 of this question paper. Just in case you want to watch question 1, I've already done a video on question 1. You can go to the description and you will see the video on question 1, and the very same video will pop up at the top right of the video that you're watching at the current moment. So before we start though, I'd like to let you know guys that I left the timestamp for each and every question on this question, just in case you don't want to watch this question in a sequence order. All right guys, so before we go to question 2, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because we have made lots and lots of videos on mathematics N4, N5, and also N3. We are done with our introduction. Let's look at question 2. All right guys, here is our question 2. As you can see, question 2 has question 2.1, 2.2, 2.3, and 2.4, with 2.2 having two sub-questions there. So we'll start with question 2.1, and then we're going to do other question later on. So let's create space so that we can do question 2.1. All right, guys, let's look at question 2.1. Given here, we have f of x, which is equaling to 1 minus x divided by x plus 2. So they want us to determine the derivative of f of x from the first principle. Now, when you derive from the first principle, there's a formula that you need to know. So I'm going to write this formula here on top, where we have f of x prime, which is equaling to limit h approaches 0, and then we have a fraction there. We have f of x plus h minus f of x. All this is divided by h. So this is a formula guys that you need to know. I've already done videos on this topic. You can go to the description. I'll leave the video there, and also the very same video will pop up at the top right of this video. Go and watch the videos on this here. Right, let's continue. We already have f of x, which is given to us. Here is our f of x there, the question. Now we need to find f of x plus h. F of x plus h, we're going to do the following. Wherever there is x, we're going to substitute with x plus h. So we have 1 minus x, but instead of writing x, in this case, we're going to write x plus h. There we go. Divide by x plus 2, but we'll write x plus h plus 2. There we go. Let's simplify our f of x plus h further. So if we continue, multiply by the negative to remove the brackets, we're going to have negative x minus h there on the numerator. On the denominator, we're just going to have x plus h plus 2. So this here is our f of x plus h. So what we need to do here is to substitute our f of x plus h and also our f of x on the formula there. Right, so let's do it. Remember, f of x prime is going to be equaling to limit h approaches 0. So we're going to write f of x first. So remember, f of x is actually 1 minus x minus h. Divide by x plus h plus 2 minus our f of x there. So f of x is the equation given to us, which is 1 minus x divided by x plus 2. There we go. Now we need to create space here so that we can continue with our question then. So when you continue, we know that all of this is actually divided by h. So rather do it this way so that you can have space here. So from here, we need to simplify what is inside the bracket there. In order for us to do this, we need to find the LCD. Now let's continue. F of x prime is equaling to limit h approaches 0. So we need to find our LCD there. Our LCD is going to be x plus h plus 2 multiplied by x plus 2. The product of these is actually our LCD. You just multiply these two there. what you're going to do here, the next step is you have to divide this here with that. So when you divide that, you'll be left with x plus 2. So this x plus 2 will multiply 1 minus x minus h. So let's do it. So x plus 2 multiplied by 1 minus x minus h. There we go. Close bracket. Minus, because we have the minus there, guys. Let's not forget. We have to put this inside the bracket, by the way. So we're going to divide this here with that. So if we divide, we'll be left with x plus h plus 2. So you're going to write x plus h plus 2. But you have to multiply that with 1 minus x. So let's do it. 1 minus x. There we go. And then we close the bracket. Then we also close the bracket and then we divide by h. Let's not forget this is divided by h, right? So let's create more space so that we can deal with the numerator there. We continue, write f of x prime limit h approaches 0 there. So on the numerator we need to FOIL to get rid of the brackets there. Let's do it. If we multiply x and 1, this is going to give us x, right? If we multiply x and negative x, this is going to give us negative x squared. If we multiply x and h, this is going to give us negative xh. There we go. If we multiply 2 and 1, this is going to give us plus 2. If we multiply 2 and negative x, this is going to give us negative 2x. If we multiply 2 and h, this is going to give us negative 2h. There we go. So we are done with this here. Let's move to the next one. Let me extend this. So we say minus. We have this minus here, guys. Let's not forget. Open bracket. Now we also need to FOIL this inside the bracket. We have x multiplied by 1. That here is going to give us x. We have x multiplied by negative x. That one is going to give us negative x squared. We have h multiplied by 1. That here is going to give us plus h. We also have h multiplied by negative x. That one is going to give us negative xh. And then we multiply 2 with 1. This here is going to give us plus 2. We multiply 2 with negative x. That here is going to give us negative 2x. Then we close the bracket there. Let's not forget we have the outer bracket. And then we're going to divide with x plus h plus 2 multiplied by x plus 2. This denominator there. Then let us not forget we have to divide by h, that h there. Now here we have to remove the brackets, these ones here, by multiplying with the negative there, right? So let's do it. So f of x prime is equaling to limit h approaches 0. So we open the bracket. For the first one, we are fine. We have x minus x squared minus hx plus 2 minus 2x minus 2h, right? And then here we have to remove the bracket by multiplying with the negative. We'll have negative x plus x squared minus h plus xh minus 2 plus 2x. All of this is going to be divided by x plus h plus 2 multiplied by x plus 2. Let us not forget all of this is also divided by h. There we go. Guys, I hope you can see what's happening here. Let me create space so that we can continue with this question. All right, before we continue, we need to look at the like terms. We have x there and negative x. These ones, they will cancel each other. We have negative x squared and positive x squared. Again, these ones, they will cancel each other. We have negative xh, this one and that one there, they will cancel each other. We have positive 2 and negative 2, they will cancel each other. We have negative 2x and positive 2x, they will cancel each other. So you're only left with negative 2h and negative h on the numerator. So let's continue and let's write with what we left on the numerator there. F of x prime is equaling to limit h approaches 0. So on the numerator, we'll be left with negative 2h and negative h. That is going to give us divided by x plus h plus 2 multiplied by x plus 2. Let us not forget we close the bracket there, and then we can say divide by h. So let's continue. If you continue, f of x prime is going to be equaling to limit h approaches 0, right? And then we're going to write everything as it is. 3h divided by x plus h plus 2 multiplied by x plus 2. We can change this division into multiplication, but when we do that, we know that our numerator is going to become the denominator and the denominator is going to become the numerator. So we're going to have 1 over h like that, right? So let's create space so that we can continue with this question. All right, before we continue, we have h and h, they will divide each other. So what you're left with here is going to be the following: negative 3 divided by x plus h plus 2 multiplied by x plus 2. There we go. So from here, we can start substituting 0 wherever there is h. Remember, h is approaching 0 there. So let's do it. It's going to be f of x prime. This time around, we don't write limit and h approaches 0 because we're going to substitute h there. So we have negative 3 divided by x plus, wherever there is h, we substitute with 0, plus 2 multiplied by x plus 2. There we go. So if you continue with this one, on the numerator is negative 3 divided by, we have x plus 2, another x plus 2 there, because this one here it's 0. So the final answer is going to be negative 3 divided by x plus 2, all of this squared. This here is our final answer. Guys, I tried to be as quick as possible, but as you know, Math 5 questions are very, very long. I hope you managed to understand this though. If this video helped you to understand how to derive from the first principle with this type of questions, do not forget to like, share, comment, and subscribe to the channel. But if you did not understand, you can always leave a comment in the comment section or watch at the point where you got confused. We are done with the first question, guys, which was 2.1. How about we go and do the second question, which is 2.2. Let's look at 2.2. Like I said earlier, 2.2 has two sub questions there. So far, we're gonna focus on 2.2.1. But first, let's read the statement here. The statement goes like this: determine dy over dx in each of the following cases. Simplification, it is not required. Right, so 2.2.1, we have the following expression there. So they want us here to actually differentiate this. So before we differentiate, you must able to identify what type of rule is this one. When I look at this, guys, I see that this is actually a product rule. We have this one as f of x, and that is g of x there. So what can we do? Let me write the formula for product rule so that you can derive this one. So dy over dx is as follow. You will derive f of x first and you multiply it by g of x plus. Then this time around you leave f of x, then you derive g of x. There we go. So this is the formula for product rule. So let's continue. Dy over dx, remember our f of x is actually x squared plus 5, all of this to the power of negative 3 over 2. So let's do it. So when you derive this one, it's gonna be negative 3 over 2 multiplied by x squared plus 5. Then we have negative 3 over 2 minus 1 multiplied by the derivative of what is inside there, which is x squared plus 5. So if we derive x squared plus 5, this is going to be 2x like that. So this here is our f of x prime multiplied by g of x. Our g of x, if you multiply by it, remember this is sec 5x squared, then close bracket there. So this part here, it's actually this part there, plus. Now this time around, on the second term, we leave f of x as it is. So f of x is x squared plus 5 to the power of negative 3 over 2, like that, multiplied by the derivative of g of x. G of x, we have sec 5x squared. So first of all, we need to derive sec. So sec, we know that it's sec 5x squared multiplied by tan 5x squared. Let me zoom down here, guys, so that we can finish this derivative. Multiply by, from here we derive 5x squared, so the derivative of 5x squared is 10x, like that, and then we are done here. So let me highlight them. This part here is actually that part there. Let's continue and simplify it further. Remember, simplification is not required, but for now, let me just simplify it so that we can all understand. So if you look at this one here, we have negative 3 there, and we have 2 and 2, so they're gonna divide each other. So we're left with x there, and then we have x squared plus 5, and then we have the exponent there, which is negative 3 over 2 minus 1. What is it that we are getting there? This is going to be negative 5 over 2, and then we multiply by sec 5x squared there we go, plus, let's look at the second term then. So we have 10x, and then we have sec 5x squared multiplied by tan 5x squared multiplied by x squared plus 5 to the power of negative 3 over 2. Right, so let's write the final answer there. We can write it like this: negative 3x multiplied by sec 5x squared, like this, divide by, this one has the negative exponent, so we can write as x squared plus 5 to the power of 5 over 2, like that, plus, now the second term we have 10x sec 5x squared multiplied by tan 5x squared. All this is divided by this one here because of the exponent is negative there, which is gonna be x squared plus 5 to the power of 3 over 2. I would say leave your answer like this. The other steps, they're not that necessary, guys. I'm just doing it so that you guys can able to understand. But this is the final answer there. Just in case, guys, you did not understand, you can always watch at the point where you got confused. If you manage to understand, you can like, comment, share, and also subscribe to the channel if you haven't subscribed. So on this question here, guys, we have used two rules here. We have used the product rule and the chain rule. If you don't know much about those rules, guys, I'm gonna leave those videos on the description, and also the videos will pop up at the top right of this video that you're watching. But we are done with 2.2.1. We'll have to go and do 2.2.2. Let's look at 2.2.2, this question here. We are given this expression here, and then they go like this, where theta is a constant. Basically, theta is just a coefficient, guys, right? So don't get confused here. Remember, we are differentiating with respect to x, not theta. That's where the confusion might happen. So when you look at this, this is actually the quotient rule. So the numerator, we can say it's f of x, and then the denominator, we can say is g of x. So when you differentiate this using quotient rule, the formula goes like this. It's gonna be f of x prime multiplied by g of x minus f of x multiplied by g of x prime. Then all this is gonna be divided by g of x, and then we square it. There we go. So this is the formula for quotient rule. So dy over dx is going to be our f of x, remember, is the numerator, 1 minus sec theta squared x. So when you derive 1, it's 0, but the derivative of sec is going to be negative sec theta squared x multiplied by tan theta squared x multiplied by, this time around we derive what is inside them. This is going to be theta squared. There we go. Multiply. Remember, we need to multiply by g of x. So our g of x here is actually theta cubed x cubed minus cot theta. There we go. Then minus. Now we move to the second part of our numerator then. So we have to write f of x as it is. Our f of x, remember, it's 1 minus sec theta squared x, like that. Close bracket. Now we have to multiply by g of x prime. Again, let me zoom out here so that we can able to finish this question. So our g of x, on the denominator we have theta cubed multiplied by x cubed minus cot theta. So the first term there, which is theta cubed multiplied by x cubed, is going to give us theta cubed multiplied by 3x squared, and then minus cot theta. We are deriving with respect to x. Cot theta is a constant, so that is going to be 0, by the way. And then we divide them, right? So when we divide, we look at our formula. Our formula states that we must have g of x squared. So we're going to write theta cubed multiplied by x cubed minus cot theta. Let's not forget, we have to square it. Here, we have to square it based on the formula. All right, so we are actually done, but we can simplify this one further so that it can look professional. Let me create some space so that we can do this one. So when we continue, dy over dx is going to be as follow. We can write negative theta squared multiplied by sec theta squared x multiplied by tan theta squared x. There we go. Multiply by theta cubed x cubed minus cot theta. Right, minus. So here we can have 3x squared multiplied by theta cubed multiplied by 1 minus sec theta squared x. Then we close the bracket there. Right, divide by, let's divide here, theta cubed x cubed minus cot theta squared. So this here, guys, is our final answer. Don't go further than this, guys. This is enough. I hope you managed to understand, guys. If this video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. If it so happened that you do not understand, you can go to the point where you got lost, rewatch at that point, and if that doesn't help, you can always leave a comment on the comment section. All right, people, we are done with this question, which was 2.2.2. Let's go do the next question, which is 2.3. All right, guys, here is our 2.3. Let's read the statement and let's solve this problem here. With the aid of logarithmic differentiation, calculate dy over dx if is equaling to ln open bracket x squared plus 7 close bracket to the power of arc cos x. So here they want us to differentiate using logs. Let's rewrite this question. You have y is equaling to open bracket ln open bracket x squared plus 7 close bracket close the outer bracket to the power of arc cos x. There we go. So here we need to introduce log for both sides. The trick here is that this one has ln already, but for the fact that this arc cos is the power of everything, we have to introduce ln both sides. So if you introduce ln on the left hand side, we're going to have ln y, and then on the right hand side we're going to have ln, and then we're going to have ln open bracket x squared plus 7 close bracket, and then we have power of arc cos x there. So from here, what can we do? We have to drop this exponent to the front then, our arc cos x. So let's do it. So we still have ln y, which is equaling to, this time around we have arc cos x multiplied by ln open bracket, we have ln open bracket x squared plus 7 close bracket and close the outer bracket. So with this now we can able to differentiate. Before we continue, we need to identify that we have product rule here. So these are two functions that are multiplying each other. So I've showed you the product rule earlier. I'm not going to write the formula. I'm just going to jump straight to the differentiation. Now, what's the derivative of ln y? Ln y is 1 over y. But since we are deriving y with respect to x, we need to multiply this with dy over dx. There we go. We have arc cos x. If you go to the formula sheet, the derivative of arc cos x is actually negative 1 divided by the root of 1 minus x squared, multiply by, now we leave this one here, it's going to be ln x squared plus 7 close bracket, and then this is what we have. Remember, product rule, we derive the first one, we leave the other one, then we say plus them. So this time around on the second term, we're going to leave a cos x and then derive ln them. So we're going to derive the first one, which is ln. So it's going to be 1 over ln x squared plus 7. There we go. Multiply. Then we derive the ln inside them, which is going to be also 1 x squared plus 7. There we go. And then we derive x squared plus 7. So x squared plus 7, this is going to give us 2x, like that. It's time for us to just simplify. So let's create space so that we can simplify this question further. So here's what you're going to do. On the left hand side, we're going to write 1 over y multiplied by dy over dx. Then on the right hand side, we have the numerator, which is negative 1 multiplied by everything there. So this is going to be negative ln, open bracket, ln, open the inner bracket, x squared plus 7, close the inner bracket, close the outer bracket. All of this is divided by root of 1 minus x squared. There we go. Plus, now here on the numerator, we have arc cos x multiplied by 1, multiplied by 1, multiplied by 2x. So you can write it as 2x multiplied by arc cos x divided by x squared plus 7 multiplied by ln x squared plus 7. Then we have to continue because we are not done, guys. So when you continue, remember we have this 1 over y. So we need to do cross multiplication. Dy over dx is going to be equaling to y. Remember, we did cross multiplication. Inside the bracket there, you're going to write negative ln, open bracket, ln x squared plus 7. And then all this is divided by the root of 1 minus x squared plus 2x multiplied by cos x divided by x squared plus 7 multiplied by ln x squared plus 7. There we go. Close bracket. Right, let me create space again so that we can write the full answer. All right, so our final answer is going to be dy over dx. Remember, y from the equation was equaling to ln, open bracket, x squared plus 7, close bracket, to the power of arc cos x, like that. But let's not forget, we have to multiply by everything here. This here is actually y. So we just equate it to the original equation there. Then we multiply by negative ln, open bracket, ln, open bracket, x squared plus 7 divided by root of 1 minus x squared plus 2x multiplied by arc cos x divided by x squared plus 7 ln x squared plus 7, and then we close the bracket. So here, guys, this is our final answer. I hope again you managed to understand this one. Just in case you did not understand, you can go to the point where you got confused, watch at that point, and if that doesn't help, you can always leave a comment in the comment section. I'll try to help you to my level best. All right, guys, if this helped you to understand this type of a question, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with this question here, which was 2.3. Let's go and do the last question, which is 2.4. All right, guys, let's look at 2.4. Given the implicit function, they want you here to actually differentiate this. Now, how are we going to do it? Remember, we're going to use implicit. So wherever there is y, when we derive, we have to multiply with dy over dx. So let's look at the terms on the left hand side. We have cos, open bracket, x squared, y cubed, close bracket. Now we have to differentiate this. So how are you going to differentiate this? We're going to start by differentiating cos. What is the derivative of cos? It's actually negative sine, and then we have x squared multiplied by y cubed, close bracket. Now we have to derive what's inside them, x squared multiplied by y cubed. So this here, it's actually a product rule. So we have to open the bracket there. With the product rule, we're going to derive x squared first. So it's going to give us 2x there, multiplied by y cubed, plus this time around we're going to leave x squared and derive y cubed. So if you derive y cubed, this is going to be 3 multiplied by y squared. But since we are deriving y with respect to x, this have to be multiplied by dy over dx. Then we close them. Then we say plus the derivative of 3x. So that is going to be 3 equaling 2. On the right hand side, we have y multiplied by cot 2x. So this one as well is a product rule. So let's derive y first. So if we derive y, this is going to be dy over dx multiplied by cot 2x, right? Plus this time around we leave y and then we derive our cot. So the derivative of cot is going to be negative 2 cosec squared 2x. Then we close the bracket there. This here is how you're supposed to derive these. Now it's time for us to group all the terms that has dy over dx on one side and the ones that don't have dy over dx on the other side. But first we need to remove the brackets on the left hand side. So we multiply by negative sine x squared y cubed with everything that is inside them. So we're gonna have negative 2x y cubed sine x squared multiplied by y cubed, close bracket, minus. Now the second term inside the bracket is going to be 3x squared y squared multiplied by dy over dx multiplied by sine x squared multiplied by y cubed. There we go. So we remove the bracket. Let's not forget plus 3. That 3 there. Right. Equaling to. On the right hand side, we just gonna multiply the y with negative 2 cosec squared 2x there. So the first term is gonna be dy over dx multiplied by cot 2x minus 2y cosec squared 2x. There we go. So let's start grouping all the terms that contains dy over dx. We're gonna transpose them to the left hand side. So if we transpose this one here, it's gonna become negative. So let's continue. We'll have negative dy over dx cot 2x. There we go. Minus. Then we have this one here, 3x squared y squared multiplied by dy over dx multiplied by sine open bracket x squared y cubed, and then this is going to be equaling to, we're going to transpose all the terms that don't have dy over dx on the right hand side. So let's do it. So we're going to start with the first one there. We have 2x y cubed sine x squared multiplied by y cubed. There we go. And then we write negative 2y cosec squared 2x. And then we transpose this 3 on the other side. It's going to be negative 3. There we go. Now let's make dy over dx subject to the formula. Let me create space here so that you can finish this question. So on the left hand side, if you take out the common factor, which is dy over dx, we'll be left with the following: negative cot 2x minus 3x squared y squared sine x squared y cubed. There we go. And then we close the bracket there. And then on the right hand side, we're just going to write it as it is. We have 2x y cubed sine x squared multiplied by y cubed minus 2y cosec squared 2x minus 3. There we go. And then we divide by everything that is inside the bracket, both sides. So here we're left with dy over dx. And then on the right hand side, we're going to be having 2xy squared sine x squared y cubed minus 2y cosec squared 2x minus 3. So all of this is going to be divided by negative cot 2x minus 3x squared y squared sine x squared multiplied by y cubed. There we go. So this is your final answer. You can multiply by negative throughout so that your answer can look like the following. Let me create space. Dy over dx. This is going to be positive 3 plus 2y cosec squared 2x minus 2xy squared sine x squared multiplied by y cubed. All this is divided by positive cot 2x plus 3x squared y squared sine x squared multiplied by y cubed. So this is basically the final answer. Guys, I hope you managed to understand this question. It was a bit long, but really it was not that challenging. If it so happened that you did not understand, again, you can always rewatch at the point where you got lost. But if you manage to understand, you can leave a comment, subscribe, and also share the video. Right, people, we are done with question 2.4. In fact, we are done with question 2. We will do question 3 on the next video. So make sure when you subscribe, you hit the bell notification so that whenever I upload the video, you'll be notified. Thank you very much, guys, for watching. Till next time, cheers.